5 equations you can see before you are known as the Suvat equations because of the 5 letters that are used inside of them. Now, you do not need to remember the equations themselves, you will be given them, but you do obviously need to know what the letters stand for. You may just be given the equation that you actually need for a question, or you may be given all of them so that you actually have to decide which one you need, and so we'll cover that in the examples that I do in a minute. But let's first of all talk about what all these letters stand for. So the first one, S, stands for displacement. Displacement is a vector, so it matters about the direction of it, but as far as you're concerned, you can take it as being the distance, which is the scalar form of displacement. And why don't they call it D for displacement? Well, because D is associated with distance, I think, is probably the answer to that. U, what does the U stand for? The U is the initial velocity. And velocity again is a vector, and its scalar form that you're more familiar with is speed. V stands for the final velocity. Again, a vector. A stands for acceleration. Now, there isn't a separate name for this when it's a vector and when it's a scalar, but it can be either. And then T is probably the most obvious. T is going to be time. Here we're told a car accelerates uniformly from rest and after 20 seconds has covered 60 meters. We're asked first of all to find out what is the acceleration. So the first thing you want to do is identify what information you've been given and what it is you want. So you want to come up with those Suvat letters. That will help you decide which equation to use. So we want the acceleration. We've been given the fact that there's a time of 20 seconds. And we've been told a displacement, a distance of 60 meters. And we've actually been given one other letter in there, but it's less obvious. And that's because it says that it started from rest, which means that the initial speed, the initial velocity was 0 because it wasn't moving at the start. So we need a formula that has A, T, S and U in. So I'm going to go back to the formulas so you can see them. We can't use the ones that have got the V in because we don't have a V. So that leaves us with S equals UT plus a half AT squared. So we want S equals UT plus a half AT squared. So now we're going to substitute what we do know in and solve to find out what A is. So S is 60, U is 0 times 20 plus a half times A, which we don't know, times the time squared. So that's 20 times 20, which is 400. So if we tidy that up, we've got 60 equals 200A. So dividing both sides by 200, we get the acceleration is 60 over 200. Divide by 10, we get 6 over 20. Divide by 2, we get 3 over 10, which as a decimal would be 0.3. And acceleration is measured, in this case, in meters per second squared. Notice that we had to square the time in there. The other way it might be written is meters still means the same thing, but with a -2, so using indices notation instead. The second part asks us what is its velocity after 1 minute. So again, let's look at what information we've got. So we want the final velocity because we want it at the end. That's what we want. What do we know? We know the initial velocity is 0. We know that the time is 1 minute. And because we've just worked it out, we know that the acceleration is 0.3 meters per second squared. Let's go back and see which formula we can use. So we've got V, U, A and T. And you'll notice that the first one is lovely. It has exactly that. So V equals U plus AT. That's what we're going to use. So that's going to be, U is nothing, so we won't bother with that. So we've got 0.3 times. Now be careful. The acceleration is in seconds. The time is in minutes. We need to turn that time into seconds. So that'll be 60 seconds. So 0.3 times 60 seconds is going to be 18 meters per second for the velocity, or it could be written using the indices form like this. In our second example, a cyclist decelerates uniformly from 15 kilometers per hour to 10 kilometers per hour in 12 minutes. How far have they travelled in that time? So what do we know? What do we want to find out? So we want to find how far. So the far will be the S. That's what we want to find out. We're told that it started at 15 kilometers per hour and ended up at 10 kilometers per hour, and we're told that the time is 12 minutes. So we need a formula this time that involves the S, the U, the V and the T. So the one that we need is the one in the middle at the top there. S equals a half U plus V T. We want S equals a half U plus V T. So we want a half 15 plus 10, and then we've got 12 minutes. Now we've got to be careful here because notice the speeds were in hours. So we actually need to convert the 12 minutes into hours, otherwise we're going to have a very dodgy answer. So 12 minutes out of an hour, which is 60, is the same as 1/5 of an hour, which means that would be 0.2 in decimal form. So we've got a half times 25 times 0.2. Do the easy thing, which is to multiply the half and the 0.2 together to get 0.1. So we've got 25 times 0.1, which is a tenth. So we want a tenth of 25. So divide 25 by 10 and we get 2.5 kilometers. We started with 2.5 kilometers is the distance that he will have travelled. Our third example has a train accelerating at a uniform rate of 0.054 meters per second squared for a distance of 2 kilometers which reaches its final velocity of 80 kilometers per hour, we're being asked for the initial velocity. So we want u. Know that the acceleration is 0.054 meters per second squared. The distance, the s, is 2 kilometers, and the final velocity v equals 80 kilometers per hour. So we've got u, a, s and v. So let's go and find our equation. So the one that we want is the second one down on the left. V squared equals u squared plus 2as. V squared equals u squared plus 2as. So v is 80, so we want 80 squared equals u squared that we're trying to find, plus 2 times, now we need to be careful here, that acceleration is in meters per second squared, but our measurement is in kilometers, our velocity is in kilometers per hour, so we need to turn that acceleration into kilometers per hour squared. So a equals 0.054 meters per second squared, 1,000 meters in a kilometer, so a will equal 0.00054 kilometers per second squared, so we needed to divide by that. Okay, so 1 hour has 60 minutes and each minute has 60 seconds, so 1 hour is 3,600 seconds. Now we want 1 hour squared, so we're going to need 3,600 squared. And what you will find out is if we times the acceleration number we had above up here by 3,600 squared and round it to the nearest whole one, we'll eventually get 700 kilometers per hour squared. You definitely need a calculator for that one. So that goes into our formula, 700 times by our distance, which is 2. So 80 squared is 6,400 squared, and then we've got 4 times 700, so that's 2,800. Taking off the 2,800, we get u squared equals 3,600, and then if we square root, we find that u will be 60 kilometers per hour.